All right, here's how you can check your review, follow along on your review sheet, and check your answers. Fix them if you do not have them correct, so you have a good resource to study from tonight. Okay, we'll start on this first page. On the first one, it says write these in exponential form. So you simply count up how many you have. B is your base, and you'll say to the fourth power. Number 2, same thing. 5 is your base. Write it in exponential form, meaning it's 5 to the third power. And go ahead and just leave your answer this way. That's what it says. I didn't say evaluate. That is coming right now. On this one, I want you to show me work. So I should have probably put that up here about showing work when necessary. I know that you have a calculator to help you out, but I want you to physically write down what this means. -5 to the fourth power means -5 times -5 times -5 times -5. That gives you positive 25. This gives you a positive 25. And then when you calculate that out, multiply, get the whole product, you get 625. This next one, 2 to the third power, expand it first. So you get 2 times 2 times 2, and then evaluate, and you get exactly 8. All right, let's continue on. Now, on number 5, it says the number of line segments between n points is 1/2 times the quantity n squared minus n. Use the formula to find the number of segments between 12 points. That means you're going to substitute 12 for n. So I'm going to start with the 1/2, and I simply, on this first stage, want you to substitute the 12 in. Then go ahead and use a calculator if you need to do 12 squared, although that should be a common one that we're going to work on memorizing. 144. And then subtract 12. All right, inside the parentheses, evaluate that first, and this gives me 132. I still then have to multiply by 1/2, and then to get your final answer, you should get exactly 66. All right, now number 6, here's one where you're getting into a nice big algebraic expression, and you have to do some substitution here. So it starts out a to the x power. A is 5. X is 1, so it's 5 to the first power, minus, in parentheses, b plus c. B is 2, c is 3. End parentheses, and the y is 2, so this is to the second power. Okay, please excuse my dear Aunt Sally says we have to do our parentheses first if we have any, which we do. 5 to the first power minus 5 to the second power. Okay, I don't need a calculator here, for goodness sakes. 5 to the second power means 5 times 5, which is 25. 5 to the first power, I'm at the exponent stage here, is simply 5, and 5 minus 25 will give me a final answer of -20. Show me this work. I've got to see it, and you'll be scored. This will be multiple points here. I want to see this initial substitution step, and then want to see some work where you expand it out and then get a final answer. All right, turn the page. Now we're getting into some of our properties of exponents. When you have the same base, it's both 4, then I can simply take the two exponents and add them together. 4 to the 15th power. Notice my instructions say leave it in exponential form. Yes, leave it in exponential form. If you did this on a calculator, it'd be a huge number. 8 to the 10th times 8 to the 5th power. This means 8 to the 10 plus 5 power, or 8 to the 15th. This would also be a huge number if we were going to evaluate it, and you would definitely use a calculator. That would be awful. Oh wait, now we have a quotient, so I'm dividing. And remember, you can always resort back to writing out what this means, 13 to the 9th power means 13 times 13 times, and so on, over 13 to the 2nd power, and you'll get two sets that divide out to be exactly 1. Or, if you remember, the pattern that we discovered and established is when it's a division problem, you simply subtract the exponents. That should be a 2. Your final answer, there we go, is 13 to the 7th power. Number 10, keep in mind this is really a 1 there, 12 to the 1st power. So when you go to simplify it, you'll get 12 to the 4 minus 1 power, which is 12 to the 3rd. Number 11, you're taking a power of a power. Keep in mind what this means. This means you're going to take 8 to the 5th times itself 8 times. Now certainly that gets a little repetitive and long, and so when we did these problems, we discovered that the pattern says take the two exponents and multiply them. That's a times dot there, by the way. And this would be 8 to the 40th power, which, by the way, would be an incredibly large number. That's why we're leaving it in exponential form. Number 12, a similar problem. 4 to the 6th power to the 8th power. My property of powers of a power says multiply the exponents. So you get 4 to the 48th power. Again, that would be another very, very large number. All right, then we switch gears on number 13, and we want to talk about scientific notation. Remember that scientific notation means we're going to take and write the number as something between 1 and 10. So I'm going to put my decimal point always right after that first significant digit. I'm including the 1, but I'm not going to write all those zeros. I'm going to account for where my decimal point really is by counting how many places I have to move my decimal point. In this case, and go ahead and draw on here to count, 1, 2, 3, 4, 5, 6, looks like 7 places. 2.1 times 10 to the 7th power. That's in scientific notation. Similarly, we use scientific notation when we have very small numbers. Like this one, oh my goodness, 0.000000003. All right, again, I'm going to put my significant digit here, the 3, and you envision that you have the decimal point right behind it. We're multiplying by a power of 10 because our place value system and our number system is based on 10, so each place value is another power. Now count how many places we have to move the decimal point to get back right there. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to move it 9 places, but I have to move it to the left, which is why you indicate that with a negative exponent. Okay, now we've got a nice little numerical expression here to evaluate. And it always says, please excuse my dear Aunt Sally, is the way I remember my order of operations. So I'm going to look at this set of parentheses first. So I'm going to put 9 to the 2nd power down here. And I'm going to focus on this. 3 to the 2nd power is 9. And 9 minus 8 is exactly 1. Oh, that's nice. Plus 5 times. Okay, now here's the deal. Normally, I would tell you, take 3 to the 3rd power. Sorry about that loudspeaker announcement. This is 27 plus 49. Oops, my ink changed color. And then it's to the 0 power. Oh, you know what? Do you remember when we did this on our calculators and we said, you know the weird thing that happens? Whenever you have anything to the 0 power, this is exactly equal to 1. So I'm going to, and check it on your calculator right now. Go ahead and add 27 and 49. That gives you something like 76. 76 to the 0 power. Oh my goodness, that's exactly 1. Cool. Come back over here. I have this to the second power, this to the second power. 9 to the second power is 81 times 1 to the second power is 1. Okay, well now this isn't so bad. 81 plus 5, I get a final value of 86. Awesome. All right, last but not least on this page, the instructions say circle the following that are not written in scientific notation. Now here's the deal. In scientific notation, the first number has to have its decimal point right after the first digit. Okay? Now for example, I look at 6.29 times 10 to the 7th power. This one is good. All right? This is in scientific notation. Notice it says I'm supposed to circle the ones that aren't. Don't circle this guy. Let's go back to the beginning here. This one says 45 times 10 to the 6th power. My decimal point's really right there. Nope. This one is not in scientific notation because that decimal point's in the wrong place. Look at this next one. I see this times 10 to the negative 5, and I'm thinking that's good, but my decimal point is right here. That is not in scientific notation because if it were, the decimal point would be between the two 8s. We said this one was good, so don't circle this third one. Let's look at this guy, 3.05. Hey, the decimal point's in a good spot, but scientific notation always uses powers of 10, not a 6. Circle this guy. This one is also not in scientific notation. All right, last but not least, we got to flip to the last page. This is the giant problem, okay? Number 17 said, Pablo predicts that X stalks of corn planted together will produce 2x squared minus X ears of corn. Make a table with the X values of 0, 1, 2, 3, 4, 5, 6. Okay, so the first thing we're going to do is crank all this out. Keep in mind, every single one of these, you're going to take 2 first, and then x squared, so whatever value we're plugging in, 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared, minus the x value, 0. This one, minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. All right, now we need to evaluate this. 2 times 0 squared is 0. Minus 0, I get 0. 2 times 1 squared. Well, 1 squared is 1. 2 times 1 is 2. Minus 1, you should get a 1. 2 times 2 squared. 2 squared is 4. 2 times 4 is 8. 8 minus 2 is 6. 3 squared is 9. 2 times 9 is 18. 18 minus 3 is 15. 2 times 4 squared. 4 squared is 16. So 2 times 16 is 32. 32 minus 4 is 28. Remember, we always do the exponent first. Please excuse my dear Aunt Sally. Exponents first. 5 squared is 25. 2 times 25 is 50. 50 minus 5 is 45. And last but not least, 6 squared is 36. If you need to write it down, go ahead. 2 times 36 is 72, and minus 6. 72 minus 6 should be 66, I think. So here are your ordered pairs. 0, 0, 1, 1, 2, 6, 3, 15, 4, 28, 5, 45, and finally 6 and 66. Notice I've got to go back and make sure, since these are ordered pairs, you need to put parentheses around them to indicate that these are coordinates on the grid. Okay, graph the table here, and notice it says labels. That's because I want you to note that on here, this should be stalks of corn, the big plants, and then on the y-axis here, these are the ears of corn. Okay? And here we go. You're going to get 0, 0. That's down here at the origin. Now, 1, 1 is going to be hard to graph because on the y value, this thing goes up by 5s. So simply put it pretty close down there to the bottom, 1, 1. 2, 6 will be right here. 3, 15. Now we're cooking. I'm right on this dot. At 4, I have 28. That'll be probably right about there. 5 and 45 is going to be right here exactly on a dot. And 6 and 66 will be right above this dot right there. Okay? Awesome. Notice this one isn't a straight line. It seems to be kind of curving upward. And if you wanted to connect those, you can. You certainly don't have to. But if you wanted to kind of sketch what this pattern is doing here, you certainly can. So it looks kind of like half of a U shape there. Finally, this last part says, if Pablo plants 7 corn plants, or 7 corn stalks, how many ears of corn does Pablo expect to harvest? So that would be simply like taking this 2x squared minus x and plugging in a 7. Show me the work like this, and then evaluate. Do your exponent first. 2 times 7 squared is 49. 2 times 49 gives me 98. And 98 minus 7 gives me a final answer of 91. Please label this, however, because this is a word problem. And it says how many ears of corn? 91 ears of corn. Excellent. Excellent, excellent. All right. This is what the test will look like. Numbers will be changed, but if you study from this, you'll be set to go. Good luck.